Okay, today we're going to go through some of the graphs to do with exponential and logarithmic functions. So tips on drawing graphs from one of the 3-4 methods assessors. So your graph must asymptote, and that is if it comes away from the asymptote, then you'll be deducted a mark. I'll show you an example of that because I'm terrible at drawing the graphs with this stylus pen that I've got here. Asymptotes must be labelled with its equation. When sketching a graph, you may not use multiple lines to try and improve the shape. So some students drawing an exponential might draw it like this and then try to improve the shape by just sort of drawing another line there, which creates a whole heap of extra functions on top of the original function. So if you are going to improve the shape, you do need to do it in pencil and then rub it out. All axes intercepts should be labelled with coordinates. If you're asked to find an inverse, remember that x and y values change. That is, if you have an asymptote at x equals 1, then the inverse asymptote will be at y equals 1. Make sure you draw the line y equals x with dashed lines using pencil. That will come up when we do an inverse function. All right, so let's draw the graph of y equals a to the x when a is greater than 1. So table of values for this. So we've got 2 to the 0, it's 1, 2 to the 1, 2, 2 to the 2, 4, 2 to the 3, 8. 2 to the negative 1 is the same as 1 over 2. 2 to the negative 2 is the same as 1 over 2 to the 2, which is 1 over 4, 1 over 8. All right, let's plot the table of values or plot those values in. 0, 1, 1, 2, 2, 4, 3, 8. Half, quarter, 8. All right, so what we're going to have is an asymptote along this line, and make sure it's literally directly on top of this line here. Okay, so it must go on top of the line, and it must be labeled. That's the function y equals 0. All right, so then what I'm going to do is try to join these dots up. Okay, let's see how I go with this. Okay, that was all good until I bumped my hand at the end there and created that. Now, what I'm going to do is just to critique a few things. Okay, first problem, doesn't go through that point. Second problem, it looks like it's actually getting closer to the asymptote here. Okay, so it gets closest to the asymptote here and kind of starts to veer away. This is also a problem. Now, what if I tried to correct it like that? That would be okay, as long as I made it clear by rubbing this out, but it's got to be really neat and smooth. Okay, so your best bet is have one complete shot at it and see if you can get it out. Okay, and if you can't, rub it out and just try again. And on the second or third go, you should get it quite well. All right, so I'm going to leave it like that because, again, I just apologize in advance. This thing is really difficult to draw these beautiful clean lines that I can do with a pencil. All right, where's the asymptote? It's at y equals 0. What's the y-intercept? It's when x is equal to 0, y is equal to 1. Let's label it. What is the domain of the function? Well, have a look at it. It'll accept any value of x. So we're going to say that's all reals. What's the range of the function? Well, the lowest value it can produce is a value extremely close to 0. Will I actually get 0? No, but I can get extremely close to 0 all the way up to positive infinity. Question, when I raise any number to an increasingly large power, will the result always increase? Okay, so have a think about it. If you think like 3 raised to the x, yes. 4 raised to the x, yes. All right, the one that won't though is half raised to the x or a quarter raised to the x. Okay, what happens then is as x gets extremely big, this gets extremely small because it's like a quarter of a quarter of a quarter. Imagine I brought in a cake and said I'm going to give you a quarter of the 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 quarter. Okay, you're going to get a very small amount of cake. That's what this YouTube clip goes through, is a bit about that and the famous Zeno's paradox problem. All right, so let's address the problem of when the base is between 0 and 1. And what this is actually decay. Okay, we're going to get decay happening here. All right, so we've got half to the x. Now, I find it much easier to write that as 2 to the negative x. Okay, that's y equals 2 to the negative x. Now, if you're not sure why that's happened, y equals half x, y equals 2 to the negative 1 to the x, and multiply together 2 to the negative x. Right, so when I jam 0 into that, I get 0. Right, when I put 1 in, I get 2 to the negative 1, which is the same as 1 over 2, which is a half. This one, if you can see there, it's going to be 1 over 2 to the 2, which is 1 over 4, 1/8. Now this is interesting. So when I put a negative number in, I just get 2 back in return. So 2 to the negative, 2 to the 1, that's going to be 2 to the 2, which is 4, 8. So it's actually the reverse of the previous graph. Okay, and if you understand what's happened here, it'll just be reflected. 4, what's that one? 2, 1, half, quarter, 8. See how I go this time. Oh, see, so that, yeah. Okay, again, same point. I missed it. That's a pencil correction. That's not too bad otherwise. Over here, probably a bit smoother around there. Okay, 1, 0, 0. When x is 0, y is 1 for that y-intercept. Now we need an asymptote, so it needs to be on the line. So I would use a ruler for that and put it directly on the line, y equals 0. Axis-intercept occurs when x is 0, y is 1. Domain is all reals. Range is 0 to infinity, just like last time. All right, so hopefully you've noted that that is just a reflection of this in the y-axis. Now, why is that so? All right, so if I've got y equals 2 to the x, what I want to do is x, y maps 2. I'm going to reflect it in the y-axis. Remember, reflections in the y-axis negate the x. So that's going to be negative x dash, y dash. Okay, so remember what we do here. X dash equals negative x, y dash equals y. And we need to solve for x over here. So it's going to be x equals negative x dash, y dash equals y. Okay, we're ready to go. We've got y dash equals 2 to the negative x dash. Let's just drop the dashes. Y equals 2 to the negative x, which is the same as y equals 2 to the negative 1 to the x, which is y equals half to the x. There you go. That is that reflected in the y-axis. Okay, some other transformations. Oh no, sketch this. Okay, so we're going to go and sketch y equals 3 to the x and 2 times 3 to the x plus 1. Now, what we're going to note here is the transformations. Hopefully you can recognize them. That there is dilation factor 3 from x-axis. Okay, now think about this like that's our function there. Think about it maybe like a parabola, and I've got y equals 2, x plus 5 all squared plus 1. So that value there represents that value there. This value here with the parabola is that which is a translation 1 up. Okay, so let's go and sketch 3 to the x. Okay, so y equals 3 to the 0, y equals 1. So our y-intercept is 1. And what we'll do is we'll just get another point for shapes. So 1 and 3. And what's going to happen is it's going to run along this line here and go through there again. That needs to go like that. You're not allowed to do that. I have to make do with the equipment I've got to do that. This is y equals 3 to the x, asymptote on here. Y equals 0. All right, now let's sketch g of x. Now, let's do x equals 0 to get the y-intercept. So 3 to the 0 is 1, 2, 3. So our y-intercept is at 3. All right, now this plus 1, what that does is it shifts the graph of 3 to the x up 1 unit. Okay, so what that will do is shift the asymptote up 1 unit. Here's 3, here's 2, here's 1. I'm going to now draw the asymptote at y equals 1. All right, now to be completely honest with you, you don't really need any other coordinates here. We're just going to get it to run through the y-intercept, and that is 0, 3. Okay, use mapping to show that when y equals 3 to the x is dilated by a factor of 1 or 2 from the y-axis, the equation is this, okay? So again, I know by recognition that this 2 actually represents a dilation factor half from the y-axis, but let's do it. Okay, so I've got x, y, and what I'm going to do is dilate by half from the y-axis, which is x on 2, comma y, x dash, y dash. That should be an arrow. X dash equals x on 2, y dash equals y, x will be x2 x dash, and let's sub those things in. So this is our original function. Let's put y dash in equals 3 to x dash, or y equals 3 to the x. Right, so all this represents is a dilation factor 2 from the y-axis. All right, so what am I going to do here? Same process as last time. 3, let's sub 0 in. 0 times 2 is 0. 3 to the 0 is 1. All right, we don't have a plus any value here. We've got a plus 0, means that the value or the function is translated 0 units up or down. So that leaves the asymptote at the same point, which is y equals 0. And all we have to do now is get something that looks exponential running through that y-intercept. That's probably my best effort. 0, 1. Okay. Sketch this thing here. That's probably as hard as it gets. Okay, so what we're going to note by recognition is this function is reflected in the y-axis, reflected in the x-axis, and it goes up 4 units. So what I imagine is that's the original 2 to the x. That's reflected in the y-axis. That's reflected in the x-axis, which looks like that. And let's raise it up 4 units. It's going to go like that. Okay, so, and the asymptote's going to be like there, 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 and there. All right, so that's what our outcome should be like. Noting, interestingly, that we're going to get an x and a y-intercept this time. Okay, let's put it together. So we know our asymptote is going to be at y equals 4. Let's work out the y-intercept occurs when x is equal to 0. 0, 2 to the 0 is 1, 1 negated is -1, -1 plus 4 is -3. Okay, that's our y-intercept. So that's 0, 3. All right, what's our x-intercept? X-intercept occurs when y is equal to 0. 0 equals -2 to the negative x plus 4. -4 equals -2 to the negative x. 4 equals 2 to the negative x. 2 to the 2 equals 2 to the negative x. Negative x equals 2 by equate the bases. X equals -2. Okay, so 1, 2, there it is there. Okay, so what's going to happen? It's very clear. Function goes up through there, tends towards there. Now I just hit the asymptote there. Again, you're not allowed to do that. Note that doesn't go through that point there. Again, you've got to get it running through your point. Again, if you understand, I'm not drawing on the screen itself. I'm drawing on this pad that sits next to the screen. So when I point there, or when I draw these things, I'm actually guessing where I have to go. So it sounds like I'm making excuses, but yeah. All right, find a sequence of transformations that takes this to this. Well, I can do this by recognition. That is a dilation factor 2 from the x-axis. This is a translation 1 unit up. All right, but just say you weren't too sure about that. What we're going to do is we're going to go from y equals 3 to the x to y equals 2 times 3 to the x plus 1. Okay, let's transpose this. We're going to go y take 1 over 2 equals 3 to the x. And let's pop some dashes in where we're heading to. Okay, let's pair them up. Y equals y dash take 1 over 2. X equals x dash. So I've paired that with that, that with that. 2y plus 1 equals y dash. Okay, so xy maps to, x dash goes there, y dash goes there. X dash is just x, y dash is 2y plus 1. All right, what's happened to y first? It's been multiplied by 2, which means it is a dilation factor 2 from x-axis. This is a plus 1, this is a translation 1 unit up. Right, so there's your exercises 3C, questions 5 and 6.